Hey folks, welcome to what will end up being your applications of matrices. So we're going to start in with some basics, finding an inverse of a matrix by hand, which will eventually help you solve a 2x2 system with matrices. So it's like a slightly easier method, and then eventually next week we'll go into some calculator stuff. So I just want you to do a little bit of a warm-up, which will help us with this unit. The first one is actually you can solve an equation for a quadratic given 3 points using systems of equations. So this is just a refresher of a 3-variable system. The nice thing is all of these represent your x and your y values, and then you can solve for a, b, and c in a quadratic equation. So we'll set up a 3-variable system. So the y value first is 9 times a to 1 squared, so that's 1, plus b times 1, plus c, because your x value is 1. The next one, your y value is 8, so you have to multiply a times 2 squared, right, because x is being squared, so that's 4, plus b times 2, plus c. And then the last equation is 5 equals a times 3 squared, plus b times 3, plus c. So, and then you just solve this system the same way that you would a normal 3-variable system way. So I would simplify this a little bit first, just like rewrite things. But I'm going to have you try to solve this system like we did before. You should know what you're doing with this because we just had our assessment on this last week. But it should be a plus b plus c if you want to get the simplified version first. 4a plus 2b plus c, and then 9a plus 3b plus c. So once you solve for or figure out what a, b, and c are, put them back into that equation. So you'll end up getting something like 2x squared plus 3x plus 6 or something. That's not what the answer is. But do that first. We don't have the calculator stuff here yet, so this is going to be all by hand for number 2. So once you're done with 1, move on to number 2. They want you to multiply a times b. The order does matter here because you can't actually do b times a. But show me a little bit of work. Some of us had some comments on Classroom last week because of not showing the work for these, which you don't know how to do them without showing the work yet, so you should have had that. So pause the video, try these out, and when you're done, I'll have the answers. All right, guys, check both answers for me. For the first one, hopefully you got negative x squared plus 2x plus 8 is your final answer. It's circled on top. If you had trouble with this, I recommend getting rid of the c's in each equation first, because then you can literally just like subtract the equations or multiply them by -1 and add. And you can pick any two to do that to get the 2-variable systems you get back. And then you can solve for b or a next because it becomes a 2-variable system. Just check if you multiplied by something, you multiplied it by it through the entire thing if you didn't get these answers. Okay, for letter B, or number 2, I mean, you have to show the work for multiplying these. So when you do finish that, you end up with -1, 32, -4, 1, and 12. If you had trouble with this, look at my work, please. But it's always remember row by column. So you have to do -1 times 1 plus 4 times 0, and so on. All right, guys, let's get into matrix inverses. So what you need to do is figure out whether something is an inverse first. How do you solve for a matrix? By finding the inverse. Same thing, like something like this, right? How do you solve for sine of x equals 1? You guys know to take the inverse of both sides. Same thing here, okay? The difference is if you end up multiplying a matrix by its inverse, you get the identity matrix. And remember, for a 2x2, which is the only one we're doing for these today, that's 1, 0, 0, 1. So if we want to show that they're inverses first, all you have to do is multiply them to see. So if we multiply these out, we can, because they're both 2 by 2s. You end up with a 2 by 2 in the end. So you're going to have to do negative 1 times 1 plus 2 times 1. And then negative 1 times negative 2 plus 2 times negative 1. Negative 1 times 1 plus 1 times 1. Negative 1 times negative 2 plus 1 times negative 1. And if you simplify that, that'll show that this is the identity, because negative 1 plus 2 is 1. 2 plus negative 2 is 0. Ooh. Negative 1 plus 1 is 0 again. And then 2 minus 1 is 1. So you end up with the identity matrix, which shows that those are inverses of each other. It's not easy to see what we did to get the inverse, so I'm going to show you how to calculate that by hand right now. All right, so again, just a reminder, the identity matrices look like this. It helps us to verify whether things are inverses of each other. The first thing you have to know how to do is find a determinant. Okay, you need that in order to find the inverse of something. Just be careful to find the determinant. You should get a number back. If you get 0, the matrix does not have an inverse. Okay. The other thing to recognize is to calculate a determinant. Sometimes they just literally say this. It looks like an absolute value, but that means determinant. Okay. You're going to take AD and subtract BC. So I'll show you how that looks in a second. In fact, let's do that with I'll make up a matrix for you. So let's pretend like we have matrix 1, 2, 3, 4. If I were just to find the determinant of that, AD are the two numbers across from each other this way, and then BC are these two. Notice they correspond to these letters. So just the determinant would be 1 times 4 minus 2 times 3. So 4 minus 6. So you would get a determinant of negative 2, okay? That's if they just ask you for the determinant. To find the inverse of a 2 by 2 matrix, just so you know, we won't do this for a 3 by 3. You'll do it all in the calc. But notice you have to do 1 over the determinant. So if this was our example, you'd do 1 over negative 2. Notice the A and the D values swapped, okay, from the original. And then you negate B and C, but don't move their positions. Okay, so we'll go through an example together and then I'll have you try. Okay, so if we find the inverse of this, remember we need to do 1 over the determinant. So I usually find the determinant first. So I want to do AD, which is 1 times negative 3. Basically, you could just think like multiply the diagonals and subtract them, if that's easier. Minus 4 times negative 1. So that gives you negative 3 plus 4. So our determinant here is 1. That's convenient. So remember, to find an inverse, you have to do 1 over the determinant, so 1 over 1 in this case, times the flipping of the actual original inverse, or the original matrix. So what that means is, remember, you gotta flip-flop these two, so just switch their positions, and literally just negate the other two. So that means change the signs. And then you distribute this through. So we're nice because we're nice. We are nice, but also this is nice because you just have to distribute through by 1. Now, if you wanted to confirm this is the inverse of the original, you would multiply A times B. The other way to write this is that, because we're used to writing inverses that way. So if they ever just give you this symbol, they mean find the inverse. If you were to multiply them, you end up with the same, you end up with the identity matrix, which if you want to test the first number, you get one times negative 3 plus 4 times 1 Haha, that gives you 1. So if you wanted to verify, you can. I'm not going to make you do that. I'm going to have you try this, though, and this is the last part of these notes. Convenient enough, they're short. So find the inverse, meaning find the determinant first. So find the determinant, and then remember you have to do 1 over the determinant times the switcheroo, distribute, and you'll have the inverse. So pause, try it, and when you're done, I'll have the answer for you. All right, guys, notice the inverse, which is right here, is not beautiful, okay? Because you have to distribute a weird looking fraction through, which is totally normal. Just be careful. If you can simplify the fractions, do so. But in this case, you don't have to, because 23 is not divisible into any of those. And again, you can verify by multiplying your original matrix by the inverse, and you should get the identity back. So again, if you want to test it, you would do 5 times 4/23 plus -1 times -3 23rds, which again gives you 23 23rds, which is 1. And then you get the same, you get 0 in the second spot and so on. Anyway, that's how you find an inverse. Sometimes they're ugly. It's okay though. Don't make them feel bad. Have a great rest of your day, guys. The rest of these are coming tomorrow.